Hello, Algebra IIers. Today we're going to talk about graphing linear functions, but we're going to use a couple different methods of doing so. We're going to talk about x and y intercepts, and we're also going to talk about this translated form. You are going to need your notebook, your foldable, calculator, and something to write with. So what should we know how to do after today's lesson? We should be able to determine the x and y intercepts of a linear function. We should be able to graph linear function using those x and y intercepts. And we should also be able to graph a linear function using the translations of y equals x on translated form. So thinking back to our last lesson, this formula right here, y equals 6x plus 5. Remember, this is your slope-intercept form, y equals mx plus b. So the m is my slope, and the b is my y-intercept. So when it asks me what is the slope here, m equals 6 over 1, and my y-intercept then is at 0, 5, because remember that's going through the y-axis at 5. So going to my graph over here, I'm going to go up 5, and I'm going to plot that first point at 0, 5. And now my slope is up 6 over 1. So I'm rising 6, so up 1, 2, 3, 4, 5. I'm going to go a little bit off the graph here. I'm going to go over 1. Okay, I could also go down 6 to the left 1. 1, 2, 3, 4, 5, 6, and go this way 1. If I just wanted some other points to make sure my line was more straight. And again, to make this line, we just connect all of those points and make sure I draw arrows on the end there. Okay, so remember, this is what we talked about last class. Moving forward then, what if the equation is not in the form y equals mx plus b? Do I have to rewrite the equation in that form, or is there an easier way to graph? That's what we're going to discuss today. So here, this equation is not in the form y equals mx plus b. Okay, now we're going to talk about how we could graph using a different method. Before we get there though, let's look at the graph below. What are the x and y intercepts? So again, remembering x and y intercepts, that's where your line passes through those axes. So my x-intercept, where this blue line passes through, my x-axis would be right here. Now if I were to label that as a point, I'm going 1, 2, 3, 4, 5, 6 to the right, so that'd be at 6, and my y value there is 0. Okay, that's the x-intercept. Now let's look at my y-intercept. So where does this line cross through my y? It's going to be right about here. Okay, and again, if I were to label this point, the x value is 0, and I went 1, 2, 3, 4 down, so that'd be a negative 4. So looking at these 2 points that I had just graphed, or picked out on my line, what do these 2 points have in common? I notice that they both have a 0, but their zeros are in different spots. Okay, so this x-intercept, the x-intercept has a y value of 0. And my y-intercept has an x value of 0. So let's go forward and get this into our note. Ways to sketch a quick graph of a line. We know we can use this slope-intercept form. Remember, that's what I call it. Get familiar with the wording. Okay, this is slope-intercept form. But we also can use those intercepts. So this is something you should jot down in your notes. So we can use those intercepts when it's not in y equals mx plus b. So the x-intercept is the point where a graph crosses the x-axis. To find it, we need to make y equal to 0. Similarly, the y-intercept is the point where the graph crosses the y-axis, and to find it, we make x 0. Then to graph this, once we've found both intercepts, we'd plot the intercepts, and we draw a line connecting the 2 points. So let's try it using the x and y intercepts. Okay, so again, remember our steps to find the x-intercept. This means y is equal to 0. So first, let's set y equal to 0. So I'm going to get 5x plus 2. Remember, y is equal to 0, so I'm going to plug in a 0 for y, equals 20. So 5x plus 0, 2 times 0 is 0, equals 20. So 5x equals 20. To solve for x, then I divide both sides by 5 to get x equals 4. So then this point, remember we plugged in 0 for y, so then x we got back was 4. So if I go right over to my graph and I graph that right away, I'm going to go to the right 4 and stop there because that's my x-intercept. Okay, in a similar way then, to solve for the y-intercept, this means x is equal to 0. So I'm going to plug in 0 for x. So 5 times 0 plus 2y equals 20. So 5 times 0 would be 0 plus 2y equals 20. 0 goes away, so I'm going to be left with 2y equals 20. Divide both sides by 2. I'm going to get y equals 10. So again, we plugged in 0 for x, and we got back a y value of 10. So if I start at the origin, I'm at 0, and I go up to 10, because this is where my graph crosses the y-axis. So now that I have my 2 points, I'm going to take my marker, my pen, my pencil, and all I'm going to do is connect them with a line. Oops. Oops. Sorry, my line's not great. Your line will be better. My line's not the best here, but draw a straight line connecting both those points, and then make sure you put the arrows on the end. So again, in example number 2, we need to find the x and y intercepts, and once we find those intercepts, we're going to use them to sketch a quick graph. So remember, to find the x-intercept, that means my y is equal to 0. Okay, so looking here, I'm going to plug in 0 for y. So 4 times 0 equals 3x minus 9. So on the left-hand side, I'm going to get 0 equals 3x, oops, minus 9. 3x, this is a minus sign. Okay, so now my x's and my numbers are on the same side, so I need to make sure I put my numbers to the other side. So I'm going to add 9 to both sides to get 9 equals 3x. And to get x alone, I'm going to divide both sides by 3 to get x equaling 3. To write this out as a point, my x value is 3, and what did I plug in for y? Remember up here I plugged in 0 for y, so my y value is 0. Going over to my graph, then I'm going to go to the right 3, my y value is 0, so I'm going to plot that first point. Okay, next I need to find the y-intercept. So to find the y-intercept, that means x is equal to 0. So when I go to my equation, I'm going to plug in a 0 for x. So 4y equals 3 times 0 minus 9. Okay, so 4y, 3 times 0 equals 0 minus 9. So 4y equals a negative 9. To get y by itself, I got to divide both sides by 4. Y equals a negative 9 over 4. So again, my x value was 0. My y value is a negative 9 over 4. Okay, so negative 9 over 4, that's going to be negative 2.25, because there's 2 4s that go into 9. We have 1/4 left over. So I'm going to go at 0, and then I'm going to go down to 2 1/4, so right about there. Okay, so when I do that, then now that I have the 2 points on my graph, I'm going to take my marker or my pen, and I'm going to draw a line. Hopefully it's better than the last one. Straight line through those points, adding arrows, and this would be the sketch of my graph using the x and y intercepts. Okay, so now what if the equation is not in the form y equals mx plus b, so not in slope-intercept, and it's not in an easy-to-find intercept form? What am I going to do? Do I have to rewrite the equation in that form, or is there an easier way to graph? So here's the example of an equation that's not in y equals mx plus b, nor is it in intercept form. So how are we going to go about graphing this form? So we already have 2 ways to sketch a quick graph of a line. Okay, we know how to use it when we're using slope-intercept form. And now we know how to do it when we're finding the intercepts. So the third way is using translations. So we're going to take a line and we're going to translate it. So the form that we need to make sure we get into our notes is y equals m times the quantity x minus h plus k. So what we're going to do with this form then is we're going to take this h value and this k value to get this point. Now notice, h is negative here, but it's positive in my point. We always have to think opposite. So when whatever we see in parentheses, we're thinking opposite. So since this one's a negative, I'm going to put a positive as my point. And the k value over here then is going to become the y value of that point. So once I pull that point out of my translated form, I'm then going to use the slope. I'm going to plot that point and use the slope, which is that m value. Remember, that's my slope. Use that slope to find a second point. And once I found the second point, then I'm going to connect the points to form a line. So let's try an example of that. So here is an equation in that translated form. Y equals m times the quantity x minus h plus k. So this 3 right here, this negative 3, that's my h value. The 4 is my k value. So the very first thing I need to figure out is what is the point that I need to graph. So remember, when it's inside parentheses, this h value is opposite of what I see. Here I see a negative 3. So when I pull it out, I have to think opposite of a negative, which is a positive 3. The k value, since it's on the outside of the parentheses, then stays the same. So 3, 4 would be the point I pull out. So I need to go to my graph. I need to graph the point 3, 4. So I go to the right 3 and I go up 4. And I graph that on my coordinate plane. Next, I need to figure out what my slope is. So my slope over here is that m value that's out front. So if I have the whole number of 2, remember that's just 2 over 1, which is rise over run. So from this point, I need to rise 2, run 1, and plot another point. And now that I have 2 points on my graph, I can draw a line that connects them, give it some arrows, and this would be a rough sketch of what my graph should look like. Trying another example, remember to write down questions if you have them, if this is getting confusing, okay? This again is in that translated form. So here I have my h value, and here I have my k value. I need to pull out that point. I'm going to change colors quick. I have to pull out that point so that I have somewhere to start. Okay, remember this h value, when it's in parentheses, I need to think opposite. So opposite of a positive 1 would be a negative 1. So the value I pull out for that h value is a negative 1. Okay, and the k value, since it's outside parentheses, would stay the same. So negative 1, negative 2 would be that point. So I'm going to go over to my graph. I'm going to go left 1, and I'm going to go down 2. And I'm going to plot that very first point. Okay, the next step then is to use my slope, which is that m value that's out front, and plot a second point. So my slope now is negative 2 over 3. Again, remember this is just that rise over run. So when I'm rising this time, that means I'm going down 2. I'm not going up because I'm negative, so I need to go down 2, and I'm going to run to the right 3. Okay, now that I have those 2 points, I can take my pencil, my marker, and I can draw a line connecting the 2 of them. Okay, and now I double check as I finish this one up. This slope over here is negative, so that means that I need to have a negative graph. As I read left to right, it needs to be going down. So my check here, it does go down as I read left to right, so this would be the correct graph for this translated form. So why am I doing this? Well, in the very near future, we're going to have to be expected to find the x-intercepts of this formula right here. Now, it looks scary, but I promise you we're going to be masters of it when it comes. So, to make sure we have our notes correct, we should have, when we're using slope-intercept form, we plot the y-intercept. This is my y-intercept. Okay, then I use my slope or my m to find a second point and connect the line, or connect the points to form a line. Next, to find intercepts, remember if I'm finding the x-intercept, that y equals 0. And if I'm finding the y-intercept, the x equals 0. So just plugging those in, finding both, plotting both those intercepts, connecting the line again, and finally those translations using this form, y equals m times the quantity x minus h plus k. We're plotting that point hk, remembering h is opposite of what you see in parentheses, k is the same since it's outside parentheses. Use the slope m on the outside to find a second point, plot both points, and connect them to form a line. So these are your notes for today. I apologize for the video getting a little long, but I thank you for taking good notes, and I will see you in class.